Math 3, I am on page 303, section 4.8. This will be the last section that I'm going to do in this chapter. And if you look down at the bottom, what we're going to be doing is expanding these powers here. It's kind of a long process, and it'll take a little bit of memorizing, but it's a whole lot easier than what they're going to do. So like what they're telling you here is if you have a binomial and you're cubing it, you have to write it out 3 times. You FOIL this. Then whatever you get from that answer, you FOIL to this one, and it can be a lengthy process. So again, like kind of like this, if I have like x minus 7 to the 5th power, what that really means is I need to take x minus 7 times x minus 7 times x minus 7, that's about 7, times x minus 7 times x minus 7, and I need to do that 5 times. So I'm going to FOIL this out, get my answers, FOIL those out, and then again take it all times x minus 7, which really would take probably the whole length of this paper to do. With the way easy to get your, multiplication or something wrong by doing all that work. So what has come up is we are going to be expanding these powers using what is called the binomial theorem on here. So what it is you have Pascal's triangle if you turn the page, and we are going to be doing it using Pascal's triangle. So how his triangle works is you put the number 1 up here. So row 0 is a 1. Row 1 has a 1, 1. And then row 2, what he does, you always start with a 1. Add the 2 above it, put it here, put it here. So then I start with a 1, add these, put a 3, add these, put a 3, end with a 1. So the next row here, which is your 4th row, start with a 1, add the 2 numbers above it, add the 2 numbers above it, add the 2 numbers above it, and end with a 1. Okay, so 5, the 5th row right here. All right, I'm going to start with the 1, add the 2 above it, 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 end with a 1. Okay, so they're kind of showing you what they're doing here, and that's how they come up. It's not a matter of whether you have to memorize this or not. You can always keep referring back to it, or you can make your own triangle. Okay, so these right here are the coefficients, the numbers that are going to be out front when you go to do your Pascal's triangle. So on this one, where it says what is the expansion of this, well, you're going to be using the 8th row of numbers, which is right here. Okay. All right, so let's just go through, and now down here, this is your binomial theorem. Okay, these numbers, the P of 0, the P of 1, the P of 2, all that stuff is going to be from Pascal's triangle. Your A right here, and here's your N, so you'll start with this number to that power. All right, and then you always drop down your power, so your A starts with, so if this were 8, you'd start with A to the 8th, and then you're always going to be subtracting 1 from each of those. Your B, which whatever is here, it has to the 0 power and then to the 1st power. So your A's are decreasing, starting with your exponent. Your B's are increasing, starting at 0 and working up. And then it just tells you right here, your P to 0, whatever, are the numbers that are in the nth row of the Pascal's triangle. So a little bit confusing, but we are going to go through and try to explain everything for you here. All right, so again, you can kind of read up here if you want. In this case right here, your A, which is what they refer to in the thing, is your 2x, and your B is the -3, okay? And they kind of explain that up here too, that your A is going to be the 3x, okay? And then your B is going to be your -3. All right, so we're to the 4th power. So I'm going to be using the 4th row of Pascal's triangle, so you can look over to your left, and the 4th row looks something like this as far as the numbers go in the triangle. So I'm going to use these numbers. All right, so the first part says I'm going to use the first thing in Pascal's triangle, then I take my A, which was 2x, and I take it to my exponent of 4. And my B, which is -3, is to an exponent of 0. Then I put a plus, and I bring down the next number in Pascal's triangle, write my A, I drop my A down a degree, so the 4 drops down to a 3, and my B increases by a degree. And I just continue with this pattern. So the next number of Pascal's triangle is 6. I drop my A down a degree, so now I'm at 2, and I increase my B to a 2. So 0, 1, 2, 4, 3, 2. All right, next number of Pascal's triangle is a 4. I take my A, I drop it down a degree, and my B, I raise it to a degree. And then I got my last number of Pascal's triangle, and again, my A goes down to a 0, so I should always end with 0. And my B should always be at whatever I started with here, to the 4th. All right, so I have all of this written out, so it's not hard. I have it written out. Now it's just a matter of doing the math. All right, well, the 1, because I'm multiplying, the 1 doesn't really matter too much, and anything to the 0 power is 1, so really I just have this right here. Well, 2 to the 4th power is 2 times 2 times 2 times 2, so I get 16, x to the 4th. All right, then I come over here. The 4 now matters. 2 to the 3rd power is 8. So really, if I was doing this, I'd probably do it in my calculator. 4 times 8 times a negative 3, because negative 3, the first power is negative 3. So I have 4 times 8 times negative 3. 4 times 8 is 32. 32 times negative 3, or I can look at it as negative 12 times 8. Anyway, when we're through here, you're going to get that. We get a negative 96 x to the 3rd. Then I'm going to come over here. Negative 3 squared is a 9. Okay. 2 squared is 4. And then I still have that 6. So I'm going to be taking, multiplying those together. So it looks like I have 24 times 9. I'm just doing my math over here on the side. 18, 19, 21, which I believe is 216. Sorry if I mess up my math here. So I forgot to get my calculator and grab it. And then I have x squared. Don't forget your variable, x squared. All right, come over here to this term. 4 times 2 to the 1st, so that's going to be 8. Negative 3 times a negative 3 times a negative 3 is negative 27. So I need to take negative 27 times 8, which is negative 216. And that would just give me x to the 1st. And then the last one, again, remember anything to the 0 power is a 1. I have a 1 here, so I'm really left with negative 3 to the 4th power. So negative 3 times a negative 3 times a negative 3 times a negative 3, which is a positive 81. So instead of writing that out 4 times and foiling, there is my polynomial equation that belongs to that using your binomial theorem expansion. Okay, it was a little lengthy. Like I said, it's not hard, it's just very lengthy. All right, so let's give this one a shot again. I'm looking at the 3rd row. So the 3rd row of Pascal's triangle looks like it goes 1, 3, 3, 1. All right, so I'm going to do 1. Take my A, which is 3A, and I do it to the 3rd. Then I do negative 7, which is my B, to the 0. Plus 3, and that's from here. Then I take my A, which is 3A squared, negative 7 to the 1st, then plus 3, and I'm going to drop this one down a degree, 3A to the 1st, negative 7 squared, and I'm going to run right into this one. Then I do my plus 1, 3A to the 0, and negative 7 to the 3rd. And then it's just, again, a matter of doing this all out. Remember, anything that 0 is 1, that one cancels, so I really have 3 to the 3rd, which is 3 times 3 times 3. Here I have this 3, 3 squared becomes a 9, so I really have 3 times 9, which is 27, times this negative 7 that's right here, which is negative 189. So I get negative 189 a squared, because I'm taking a to the 2nd power. Here it looks like I have 3 times 3 times 7 squared. 7 squared is 49, so 49 times 9. 81, 36 is 4. I think it's 441. Again, please check my math on this. I'm again trying to do it on just off on the side of the paper over here. Okay, and let's see, back to this one. This is a 1. That's just becomes a 1, so I'm left with negative 7 times -7 times -7. Let's see, so 63, you get 28, -343. So there is your finished answer. Notice how your A's all go down in decreasing order, and then the signs also change. So positive, negative, and that's because of this negative here. If this were a positive, then they'd all be positives. All right, so that's kind of what we're doing. Now, some of your questions, if you take a look over on page 307, it doesn't ask you to expand it all out. It just asks you for a certain term. So I just want the fourth term. So let me go back to our answer. And like on this one, if I asked you for the second term is right here. So how do we get it? Well, if it's the second term, then you've already decreased this down by 1 and you've increased that one by 1. Now, keep in mind, these right here always add together to get this exponent that's here. So whenever you're doing exponents, they should always add together to get that one. All right, when you're going through. So let's just, all right, we're on page 306, okay, and I have this one. So let's say I want the third term of this one. All right, so I'm to the 5th power, so I go to my Pascal's triangle, and I look at the 5th row, the third term. So I got a 10 in front of it, okay? All right, hold tight, third term, yep. So I have a 10, so I'm gonna bring that 10 out. All right, I'm gonna do my X. Now, the first term was to the 5th power, the second term was to the 4th, and the third term will be to the 3rd power. So I have X to the 3rd power. Then I'm going to have a -2, and remember these two exponents have to add to 5, so that has to be squared. Now all I do is just do this power. So -2 squared is 4, 4 times 10 is 40, so it's 40, X to the 3rd is going to be my third term. Okay, that is it, and I will put the homework on Google Classroom.